Afternoon, evening, I guess if you're on East Coast time like most of us are. It's a nice dinner that we're all having together. So the way that we wanted to break this up is like Ken said, we've been doing a kind of a roadshow type maneuver. So we've been with Army, we've been with Air Force at Hanscom, we were at Navy last week. And so we've essentially been coming in and saying we all know that HBSS 1 has been here for a while. 2, contract renewals and upgrades are in progress. And then 3, it's been a little while since we've been able to engage different segments of different commands, one of them being Asia Pacific. So I cover DoD, I get a little ring back here. I cover DoD at a high kind of broad scale across large customers, enterprise developments, taking all of our products and partners and putting them into solutions that we can package up and then hand to customers and say, you don't have to do a bunch of integration, you don't have to go out and buy 16 different things. There's just, you have a problem, here's the top to bottom kind of stack with us and partners. And then Derrick is one of our engineering staff who covers specifically Asia Pacific. So if you've got Asia Pacific questions or if you want updates on what the theater is doing, he's here as well. So we'll kind of tag team this back and forth. From an agenda standpoint, what we wanted to do was do an EPO brief. So just to get a vibe in the room real quick, how many people are familiar with HBSS from a technical standpoint? Okay, how many people would benefit from a quick overview of the HBSS foundation technologies, things like that? Yeah, okay, great. So I'll do that really quick. It's not in the slides, but I think we'll all follow. Then what we're going to do is take you through a brief on ENS. So ENS is our new endpoint technology that it's not that we have something brand new that we are saying, take HBSS and do this thing. Essentially what we're saying is that what we've learned from HBSS and endpoint deployments around the world essentially has migrated us to a point where now we see a better way of doing things. So it's the logical and natural progression of the product lines all merging into what we call ENS, endpoint security. And at some point, we haven't announced it yet, but at some point we will actually end of life the legacy modules is what we're calling them that you see in HBSS. So we want to give you an oversight on what that is, get feedback. If you have questions, I'd ask you to just ask them whenever you have them so we can kind of pace ourselves through the day. And then what we're going to do is we're going to do an app control brief. So app control is whitelisting. DISA is doing acquisitions on this now. They're going to provide it to the field in kind of an enterprise view. So I'm going to give you a brief overview of what app control is, benefits, use cases, what the DoD is trying to target with it, take questions if you guys have some, and then we'll also talk about how you can enable app control in your environments to protect infrastructure. And then at the end, since we have 2 hours, at the end we're going to do what our vision is. So there's a lot of people that ask us, HBSS is 8 years old. Are you guys comfortable with that? And the answer really is that working with DISA, sometimes the Department of Defense moves a little slow. So what we're doing is we're taking the opportunity to kind of do an upgrade to current cutting edge market technology that we see both on the commercial side and enterprise. We want to get the Department of Defense to these newer technologies. And so what we're going to give you at the end is an overview of what those are, how they work together, kind of our vision, which is what Ken was talking about. And then Derrick's going to be nice enough we have a video, it's about 5 minutes long. It's one of the walkthrough demos. And so he's going to narrate that for you and kind of talk about not only how this works, but how it works specifically for Department of Defense. So if there's no questions, I'll give you a quick overview of HBSS real quick, and then we'll dive into EPO. So if you're unfamiliar, HBSS, host-based security system, DISA program, sorry about that, DISA program, and it's been in business for about 8 years, something like that, maybe a little bit longer. It's been through a lot of evolution, so we've upgraded products, we've upgraded the program, different deploy techniques. There's been different orders for IGO 13 being one of the first for rapid deployment. And essentially what the Department of Defense did, which is a great idea, is they said we want to standardize everyone on an endpoint solution so that if we go across the board and you look at Army, Air Force, any CCSA, you can essentially say, are you running HBSS? And the answer to that question is yes or no. And if the answer is yes, because you're mandated to, then there should be some commonality, right? They know what modules will be installed. There's orders and STIGs that tell you how to configure it. And so it's kind of everyone starts at this level playing field where everyone walking into the conversation should be at an equal playing field. We've built into HBSS, so after the Manning incident with USBs and CDs, we added some technologies to do removable media. So as things have happened over 8 years, we've added technologies into it. But like I said, we've never really been able to do that big move to get everyone current. So that's what we're hoping to do in the near future. From a technology standpoint, it kind of breaks out into a protection profile, and then there's this kind of auditing profile. So we have a tool that, and I'll talk about it a little bit, we have a tool that does local IPS, so signature-based detection. We're looking for buffer overflows. We're looking for malicious API calls. There's tons of signatures, and if you've ever used HBSS, people usually will tell us in feedback sessions, love to get feedback from you guys as well. They say usually HBSS is time-consuming and it's hard, and what they actually mean by that, what we found, is that HIPS, host intrusion prevention, is time-consuming and hard. It's the other modules really aren't bad when you start talking about it from a workload standpoint. So HIPS is kind of the work share of it. That's where you see a lot of the custom signatures. As NSA creates tippers from what they see as campaigns or attack sequences, HIPS is the workhorse that we go to say, okay, we're going to create custom signatures for the Department of Defense. We're going to push those out, automate the detection, blocking, things like that. There's a malware scanner, virus scan, so it sets on the endpoints, on-demand, heuristic, and DAT protection from malware. And then we have Policy Auditor, which we're trying to get the news out on this. It's been part of the program for a long time, and it just doesn't seem like people have used it efficiently. But it can automate STIG compliance for you. It can automate patch compliance. We're using it for the cyber scorecard now. We have a couple of proof of concepts going on right now to automate the cyber scorecard using Policy Auditor. So that's in the portfolio. And then this piece, which is EPO, ePolicy Orchestrator, is the command and control center. So this is one of the things that we did a long time ago. Probably one of the smartest things as a company we did is we said all of our endpoint technologies, we want one common console. We do not want customers, if they come to us to say, well, we really need data loss prevention, to say, I need you to deploy this product and also stand up this new management center and train people on this new manager and SQL backend database, which you need licensing for. Essentially what we said is once you get EPO into the environment, the workflows stay the same, and if you want to deploy new tools, all you have to do is check in the package and maybe train on the tool itself, but the interface stays the same, right? It's all kind of a workflow model. And so as we talk about this, the reason that we usually do the EPO update first in these sessions is because EPO is literally the backbone of the entire HBSS portfolio. Everything we do in HBSS revolves around you logging into EPO and then doing something, whether it's looking at events, deploying products, changing policy, incident response, and we'll kind of walk through that. And then, kind of on the backside, we've added, and I'll walk through this as we go, but we've added some technologies recently that get us, kind of up to speed. If you're familiar with the NASCAR initiative, NIPR, SIPR, Cybersecurity Architecture Review, NASCAR spelt wrong. They essentially, OSD, DISA, and NSA essentially have looked at it and said there are gaps inside the Department of Defense. We want to make a list of these gaps. We want to align funding to those, prioritize those, and then really target those for enterprise acquisitions. Interesting is, and we'll go through this when we get to it, but interesting if you look at NSA's top 10 mitigations that they say if you do these things, IED says you'll be better protected. And then if you go over on the other side and you talk to the TAO guys, they essentially say here's the 5 things that you could do to make our job harder. Those people that they try for a living to get access to systems. And application whitelisting has historically always been number one on both lists. And so it was interesting that someone finally had an idea and said, well, why haven't we as the DoD moved out on application whitelisting then? So they listed as NASCAR's #1 requirement, and we just fulfilled that requirement recently with DISA. And I'll go through and we do the app control brief on how we were able to do that. Whitelisting, incredibly hard problem to solve, and we have a great solution for it. So like I said, we've added some things into the HBSS portfolio, but that's kind of the high-level gist on that. Any questions from a baseline perspective before you get started on the kind of update and brief for EPO? And please feel free to ask questions as we go through. All right, so this is our standard safe harbor agreement, meaning that some of the stuff I'm going to talk about may be releases that are a month out, 6 months out. We hold the right and responsibility to change those at any point we want, and we cannot be held responsible. So I legally have to tell you that. EPO, you'll see at the bottom, quick caveat, that it says on-prem. The DoD is not doing this yet, but if you are familiar or interested with cloud deployments, AWS, Azure, or something like that, please feel free to swing by our booth. We actually have EPO running in a cloud environment. So if you are a small customer, one day, probably not right now for the DoD, but one day, it's very possible that instead of having hardware on site, you'll just spin up a cloud infrastructure. So all of this, though, is focused on on-prem because the Department of Defense only uses on-prem. So here's your kind of high-level architecture. So if you're not familiar with EPO, essentially what you have is a web interface. And on the back side of that, you've got a server running a web server and a SQL database. It's one of everyone always say, how's it scale? We have deployments that are 350,000 assets, meaning that they manage 350,000 assets. And we have deployments that are 5 assets. So you can virtualize it, you can put it on hardware, you can separate it, SQL and the app server running on different hardware. You can do about anything you want with it. But what it provides you, and you'll see it down here, is management of local assets. So if you're familiar with the new kind of workflows for EPO, the interface has changed quite a bit, and there's a reason for that, and I'll go through that in one of these next slides. But simple things like deploying products sometimes in the past took 10 to 15 clicks. Doesn't really make sense, right? And that's one of the benefits of working with the Department of Defense for 8 years is a lot of the stuff we do, you look back at from internal to the company, and I find myself wondering, I don't know why we didn't do that to start with. It just makes sense, right? Should be one page with 3 clicks instead of 2 pages with 15 clicks. But as you're developing these products and putting them out in the field, those things don't necessarily pop up. So we've went through a user experience update. But what you can see down here, it's kind of sprawling, right? Is that no matter what your endpoint is, you can connect it, manage it, deploy, and policy with EPO. So if you have mobile devices, we have partnerships with the major mobile vendors. Mobile Iron, that's what we all have on our phones, right? So you can see those events, you can see those systems, all in EPO. If you want to deploy additional product outside of HBSS, EPO. If you want to bring in partner products, so we have an SIA Security Innovation Alliance. It's got about 300 and some vendors in it. If you find a technology that we tell you we don't compete there, we're not best in industry, so we're not going to even try to give you a mediocre product. We go out and partner with leading best-in-breed technologies. A lot of those have EPO integrations. So even in the Department of Defense, interesting enough, for a while, the semantic endpoint was actually being, the events and policy management was being done in EPO because DISA wanted a central management console for HBSS. So there's a lot we can do there. But it's extensible, so you can deploy different, if you've got a DMZ, you can push out an architecture, support that as well. Any EPO baseline questions before we actually get into after this piece, there's going to make a big assumption that we all know what EPO is and start looking at some of the new features. Okay, so EPO 5.1, the reason I'm going to show you this, if you're familiar with the Department of Defense, we did not launch this in the Department of Defense. DISA kind of passed on this. They said, because of timelines, we'd rather wait for what we were calling 5.3. But the reason I want to show you this is because each one of the slides has what we did in that release, and then we don't put all the same bullets on the next slide. So what we did in 5.1 to help specifically some of the DoD units was, one, this is the one that we tagged and said this one will become FIPS compliant, and so will the later releases. So we targeted this and said, long-term release, we did an NSA code review on it, and we took it through FIPS compliance. On the usability side, people have always asked, what do we do for disaster recovery with EPO? If it crashes, how do I get it back up? And if I have an SLA with a customer as a contractor or the government, and you say it's mission critical, it's running our security system, I want this thing back up. We've always used our services division to create these custom disaster recovery plans. It didn't really make sense. That's one of those moments where we're like, this doesn't make sense. So what we did is we built in a disaster recovery. It's not a hot standby. It is literally a cold standby. So essentially what happens is we use the database to pull everything we would need to bring it back up in its current state. We store all that in a database table. You replicate that database table to a separate server geographically dispersed. In the hypothetical that your EPO server crashes, essentially you grab a new piece of hardware, you run the EPO installer, and instead of running the installer, the first thing it says is, are you doing a new install or are you recovering? And you say recovering, you pointed at that database recovery, and in about 30 minutes, boom, your server's back up, keys are there, it knows about all the agents, policies are already set. So it's literally just a cold standby maneuver. And then the workflow improvements, right? So the single page for deployment, it sounds simple, but if you've used HBSS in the past, one of the things people always shook their head at was, oh, I have to click 15 buttons and 3 screens just to deploy product. I mean, the technology knows how to do it instantly, so why can't we just click, 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 go? So that's what we moved to, and you'll see that on kind of the side over there is we have these unified workflows now. We actually hired consultants to tell us where the user experience was lacking in the technology, where it wasn't a technology issue, it was just a user experience issue. And so a lot of those went into 5.1. And we also did things like URL-based installs. So if you have situations where you have systems that administrators are responsible for maybe provisioning, and then telling you that they need to have HBSS extended and deployed to them, what we've created is a situation where essentially you can say, as you provision new systems, here's a URL, and as soon as the system's up, go to this, click the URL in a browser, and essentially it pulls down the package and installs it with predetermined credentials. And so that's one way that we've kind of made this management deployment a little bit easier for you. Any questions on any of these features? Yes, sir?
I noticed you said about FIPS compliance.
Yes.
Not validated, or is it validated?
It is. So it's 140-2 third-party validated. And I don't know how detailed we want to get, but what we used to do was pay someone to validate those. What we're doing now essentially is using the pre-certified RSA libraries. And so that's one of the things is it took us a while to actually go out, and so we'd have to tell DISA, it's in process, but we're paying someone to third-party validate this, because everyone knows that if a company says, I'm 148-2 compliance and validated, and you're like, who validated it? You're like, I did. No one trusts that. So we would pay people to validate those, which extended our timeline. And so DISA would get in a situation where they say, well, we don't really want to release it till it's validated. And so what we did is made the decision that we'd rather pay the money to invest in the modules that are pre-validated. We use those in the crypto libraries, and day one, we can essentially say, by proxy, these libraries are validated, so are we. And that's how we've done all of the accreditation packages.
Related to common criteria.
Yes, I don't list it here, but yes, it is common criteria. I'm trying to remember what level we did, but yes, we have all of that if you have it. And it's all in the DISA accreditation package, so we can get that for you as well. Any other questions on these features? All right, so this is what you will be seeing. How many people are on 5.3 currently? Okay. What's everyone else on? 4.6? 5.1? No EPO servers, okay, that's good. Yeah, so if you're on the 4.6, we talked to the Navy last week. I think it's one of the things that I've learned working with the Department of Defense is that people don't do these things just because they think they're a good idea. A lot of it's necessity and need. Mission systems, things that you can't update, ships. So we understand people are on that. The reason we're trying to get everyone on 5.3 is because there was a rash for a while of third-party vulnerabilities. So there were vulnerabilities discovered in OpenSSL. There were vulnerabilities discovered in Apache. There were Java vulnerabilities, there were Tomcat vulnerabilities, and so we've been doing this rapid clip to essentially get these things updated, and one of the things that we told DISA was that as of the 5.3 build, all of the known vulnerabilities were built in, and essentially we had patched and remediated all those in that build instead of having to look at someone and say, you didn't install this hotfix or this patch because OpenSSL is vulnerable, and since we use it, we need to patch. So DISA is focusing on 5.3 for a long-term release, meaning that we're gonna get that out and stable. So hopefully you've looked at it. If not, let us know. We can absolutely do demos, briefs. If you want it in a lab, help you install it. DISA has the images now, so you can actually get the 5.3 image and spin it up in a lab. But here's some of the things we did, and I think these will probably look good for a lot of people that have used HBSS. One of the things that has always driven me crazy about EPO is if you install a product extension, and the extensions control the policy, deployments, tasks, things like that. If you install the extension and the extension, for whatever reason, you thought, I need to remove it, or you just have an administrator who's new and they see something, they're like, I don't know what that is, I'm just going to remove it. Essentially what it did is it removed everything assigned to it. So it removed all of your policies, all of your tasks, and it made sense because the extension was the owner of that stuff in the database. So when you remove the extension, it essentially says, I'm going to remove all of these associated items. Now what we've done is said, that's not going to happen. You have that option, but default, when you remove the extension, it doesn't actually remove all the associations to it. So hypothetically, if you have an administrator who makes a mistake, or if we tell you you need to remove the extension and check in a new one to solve a problem, that won't remove all of the associated things. So for the DoD, that should be huge. And then you can also set a McAfee agent contact priority. So in the DoD, there's mandates on how often the McAfee agent, which is what sets on the endpoint, has to check into the server to get new product updates, policy, events, things like that. So now you can actually set that priority and say, you will, 100%, you will check in on these thresholds. And then there's some other interesting things we did that may not be 100% huge moves in the DoD. The view the third-party product versions is huge. So when we had the rash of third-party vulnerabilities, OpenSSL, Apache, Java, stuff like that, we essentially were telling customers, here's the patch. Specifically in the Department of Defense, everyone was like, that's great that I applied the patch, but my security administrator, IAM, they want to see where the version's been updated. They want me to actually show them that I've applied this patch and Java is now updated to a non-vulnerable version. And so we had you go to a system configuration file and say, open this configuration file, there's the version, take a copy of that. Again, one of those moments where you're like, made sense in the moment. When we had a new release, we all said, why wouldn't we just put that in the interface? So why can't I just open the EPO interface and go to the system settings and it actually tells me, here's your version of a Java, Apache, Tomcat, OpenSSL. So we put all that there for you. Doesn't sound like a big move, but this is kind of our partner moment with the DoD to say, we all know you guys were doing this and it was taking, maybe it's only 5 minutes, but if you have to do this on multiple servers, it's a pain. So what we did is we incorporated that in the main interface. Yes, sir?
Does this in competition with, or does this replace ACCM?
So ACCM is an inventory and compliance measuring tool. So what the goal, I'll tell you the goal of ACCM, and then we can talk about how we're helping with that. The goal of ACCM was it was supposed to pull an application inventory on the endpoint. So the first problem is when the Department of Defense says, how many vulnerable versions of Java do we have? The problem is from a DoD standpoint, I don't know how many versions. I don't know the systems have Java installed, period. So how can I tell you the version? And so what ACCM was supposed to do is pull the inventory of the system, and then what they extended it to do was to say, here's the correct version, here's the vulnerable version, record that, pull that, do everything you do. From an outside standpoint, because it's a GOTS tool, it's not ours. From an outside standpoint, we found that it was flaky at best. It just crawls the registry. And so the problem is in a lot of cases, it was looking at registry entries that may not be accurate. There's a lot of times you can install a product, remove a product, update a product, and that registry key may not actually change. And so when they were reporting all of these application versions, a lot of them were wrong. Some of them were just completely inaccurate. The product's not even installed. And then when they started doing the mapping, they're not looking. ACCM today doesn't actually look at the DLL for the version. And so that also doesn't change, right? So if you install a patch and it upgrades you to the right version of the application, and then you install another patch, it may retroactively downgrade that first patch, but the problem is the version now is higher. And so when you look at it from a compliance standpoint, you look at it and you say, oh, that version's higher than the patch that I need, so I must be good. But when you go look at the DLL, which is the actual vulnerable piece of it, the version on the DLL may actually have got downgraded and now you're vulnerable again. And so there's a couple of tricky things about it. We have not replaced it. DISA is working with us to say, is there a better way to do this? And the answer is obviously yes.
So the long-term idea for ACCM was to determine IAVM compliance.
Correct.
So your view into third-party product versions, is that the long-term goal for that?
Yeah, so let me clarify. Third-party product version on this slide is specifically related to the EPO application itself. Its own libraries it's leveraging. Yeah. What we do, and it's a great question. So we do that with Policy Auditor. That's what we've extended to DISA in a white paper, is to say Policy Auditor looks at the DLLs. We've done the CVE to IAVA matching, which doesn't sound like a hard thing. Why can't you guys just take CVEs, which is the industry standard, and map those to IAVAs? But having people do that on a regular basis, especially when the IAVA process is confusing at times, we've got really good at that. So right now we're shipping both mapping from CVEs to IAVAs and Policy Auditor. We're shipping STIG compliance in Policy Auditor. So you can actually download, in EPO, you've got something that says Windows 7 STIG compliance. And it's Cat 1s, Cat 2s. And you can run a profile for all Cat 1s and Cat 2s. And so we're doing that at the endpoint with Policy Auditor, which is reported to EPO. And so what we've told this is, give us the 2 or 3 things that ACCM is possibly doing for you that Policy Auditor is not, and we'll tell you whether or not we can just shift those inside of a product release and give it to you under your license that you currently have. And so we're working through that right now. Right now, we're about 80% of what it's supposed to be doing is done in Policy Auditor. Any other questions on the EPO 5.3 piece? Yes, ma'am. Mm-hmm. Correct. We have. So, so the with HBSS, essentially what we say is, EPO doesn't really care about your endpoint. What it cares about is the McAfee agent on your endpoint, which is reporting back. And so we've done a matrix and essentially said we support Windows 10 on all of our major products that are part of HBSS. We support the McAfee agent. The McAfee agent version that supports Windows 10 is supported in all major supported releases of EPO. DoD specific is Windows 10 is not a good target for us because the Department of Defense isn't going to use Windows 10. They're going to use Securo's baseline. And so when we started doing testing, it was Windows 10 we may work on. When we take Securo's baseline, which is an NSA hardened Windows 10 image with all these different configurations and different security modules for a good reason enabled, we need to retest. And so what we're tracking for the Department of Defense right now is, do you support Windows 10? Our answer is yes, and we also support SHB. Because tracking Windows 10 in a DoD environment doesn't really get us anywhere. Because we fully expect, per Mr. Halverson, that everyone will be moving to SHB, Securo's baseline, in the near future. And everyone's going to have their revisions. We talked to Major General Baker with Netcom, and he was like, well, we're going to have what he called Sheba, the Securo's baseline Army revision. And so everyone's going to kind of modify these, which, to be honest, from a vendor standpoint, makes it harder to look at you in the eye and say 100% we support SHB when everyone kind of modifies them. But what we're aiming at is a base, we get the SHB image from DISA, we put it in our labs, we run all the products against it, and we return to them a yes, no, and then we work with Microsoft if we need to modify things. So.
Currently
Yeah, I mean, the EPO release is kind of a high-level manager piece, but I have a mapping for the HBSS product, and this supports all of those. Yep, yep, yeah. We have all of that available. I think for those of you who aren't familiar, DISA has a thing called the DoD Patch Repository, and it's this location where they put binaries and updates and documentation. And so on that patch repository, I believe, don't quote me on this, but I'm almost 100% sure, say 97, that there's a matrix that we created for them that essentially says, if you're going to run Windows 10 SHB, you need these versions. These are what we've tested. And we can work through it like that. That's a great question. Any other questions on either this or how we're supporting operating systems? Quick question. How many people are still running XP systems? Everyone laughs. I don't know if that's like we all are or like, haha, those people running XP. No, I mean, seriously, that is a discussion that we could have today because Windows 2003 and XP. We know that there's Department of Defense communities that literally just can't get off of them, right? Like whether it's right or wrong, whether it's ridiculous or not, from a vendor standpoint, we have to support that somehow. What we've committed to doing is supporting them with a different strategy. So if I take the full HBSS load, I essentially have to test all of those products on an operating system that the vendor won't even support me on. So if I say, the new version of VirusScan breaks XP SP2 or SP3, then essentially what I'm stuck with is calling Microsoft and saying, I think that it's a driver conflict. Can you fix this? And they say, we don't support that operating system anymore. So if we were to somehow, in a hypothetical blue screen, an XP machine, and the fix required Microsoft and us to jointly do something, we hypothetically wouldn't be able to fix it because they're not going to support it. So what we've done is backed away from that and said we 100% agree we have to provide you something to secure these systems. And so the application control, the whitelisting tool that we're going to talk about here in a second, we've essentially said until late 2017, and we may even extend that, don't quote me on that, we may shift a little bit, we will support XP in 2003 with this whitelisting tool because it's easier to lay down, there's less driver conflicts potentially, and it's, essentially those XP systems should only be running certain applications under kind of the conversations we have is there are a lot of, program of record systems, they're afloat, they're tactical, they're mission critical, what we call DDIL, disconnected, disadvantaged, intermittent, limited bandwidth systems. So they're easy to whitelist because they should only be doing a couple things. So we'll talk through that. And then 2003 as well. Is anyone actually running 2003? XP we hear a lot of, but I haven't heard too many people actually still running Windows 2003 Server. No one? Same conversation, just different platform. So this is what is coming. We have 5.3 is what DISA has released into an image and accreditation. They're testing an early release of 5.9 now. 5.9 hypothetically will be out probably in about 2-3 weeks. Like I said at the beginning, safe harbor agreement. If we find an issue or we want to extend testing, we may extend that. But Q4 is what we're saying this year, our calendar year. So here's what we're doing. It's not a massive usability thing for customers. This one was a necessity. So we saw everyone started asking us, can we use more secure keys? Can we use 2048 instead of 1024? And so we were like, yeah, we can do that. We saw the move to SHA-2. So we saw that coming. And so we said we got to have a release that is going to implement SHA-2 instead of SHA-1 root SIGs. And then we also did a big int. So if you're unfamiliar with that, essentially what's happening is that our customers are using EPO for so many things that the database and the way we've done the database schema, it won't support some of the number of data elements that are in it. So we have to upgrade that database in the back end to use big int. And if you want to know what that is, we can talk about it offline. I don't think it's that entertaining. But so these are more functional things that we had to do to support large enterprise environments like the Department of Defense. So we're doing that in 5.9. In 5.9, we also brought a couple interesting things that I know all of your security teams are going to ask about is this, because we're getting this from DISA, when can we expect 1048 SSL signatures? And so the answer to that is 5.9. So when you move to 5.9, you can look at your security team and say all of our communication with HBSS now is secured by a 1048-bit SSL encrypted key instead of 1024. So that was something that DISA asked us for a little while back. So that's one. And then the second one is the certificate manager. Right now, if you've been with HBSS since the beginning, there were all these scripts that you ran to generate certificates, self-generated certificates, and then you'd get a certificate from the PKE team from DISA, and you'd import that into your EPO server, and a lot of this was done in custom scripts that we created on behalf of DISA in the past. Another one of those reflection moments where we said, wouldn't it be nice if we just had a certificate manager inside EPO, where it's import, export, button clicking, no script running, modifying, command line type stuff. So in 5.9, we officially stepped full foot into that. We've done a little bit adding incremental increases, but in 5.9, we have a certificate manager built into it. So now we'll change all the DoD guidance that we write guides for, and we'll essentially say when you get new certificates, this is how you do it in 5.9 instead of running these scripts and trying to troubleshoot and support those. Any questions on the certificates? Okay. And then big int. So yeah, if you want to know what the big change is, I won't count zeros for you, but int is what we're using currently. And so you can see there that we've got about 2 billion event or data type max values. And when we move to big int, I don't even know what that number is, but it's massive. And we're doing that because, one, like I said, we're using EPO in the cloud. And so as we moved EPO to the cloud, we changed the cloud backend architecture and moved to more of like a big data solution with Hadoop. And when we did that, we realized that, wow, we can consume a crazy amount of data, crunch all that, and provide a really cool analytics view to the consumer. The problem is the on-prem database solution wouldn't support the same type of capability because we were restricted by the data sizing. So in 5.9, we literally will, for you, update your database to account for these new big int changes. And then that allows us to give you some really cool reporting and analytic technology in the future releases. Any questions on that piece? And I'm going to cover this in a second, but the big thing that we should all reflect on is in order to do that, we essentially are taking your database, and during the 5.9 installer, we're upgrading that database. And so I know in the Department of Defense, we've historically not been great at purging data out of our EPO databases. So some people have 4 years of events, and you're required to have 2, right? So why do you have 4 years of events? Well, probably because somebody either wanted to look at them or local security policy, something. Or we'll tell people to use policy audit for STIG compliance, and they've got 4 years of STIG compliance data, which is massive. No reason really to have that inside the server. And so one of the things that we're telling people and we're educating people on right now is if you've got 20 terabytes of SQL data, it's going to take me a while to upgrade that in the 5.9 installer. And so that server may be unavailable for a while we're upgrading the backend SQL server. So I'll walk you through some of the ways we've created to help you with that. But as if you're security administrators or HBSS admins, the big concern that I had was that if somebody in the Department of Defense says, here's my ASI, my service window, I expect historically that the EPO server usually takes about an hour to maybe do a database upgrade or something like that. We do it once a year. This may be longer, and I would hate for someone to schedule a 30-minute ASI or an hour ASI to then have somebody call and say, this thing's going to take 8 hours because we have 30 terabytes of data we're trying to upgrade, right? So we've created some tools that, one, estimate how long it's going to take. We've created tools to tell you where you can prune data that just shouldn't be there, that you should remove. We've created some tools that tell you your database health, and I'll walk you through those. And all of those things are to help you. They're free tools. There's extensions to check in. DISA has already evaluated those, and they're drafting guidance, DoD doctrine, on how to use those, what we should be concerned about. So we're going to help you here, but this is kind of a one and done. We're going to do this big int change in 5.9, and then in the future, we won't have to do any big, massive database changes, unless we do decide to move to that kind of different architecture where we say, SQL's really expensive. I think everyone understands that. The model changes about every other year. Now I think it's for every 2 core you have to have a SQL license. It's who knows how much that is, $10,000, something like that. And so the Department of Defense is spending a lot of money on SQL, and so we want to do our job to say if that's not the most effective solution, we want to find new ways to do it. We don't want to just say, well, we've been doing it like that for a while now and it's stable, let's stick with it. We want to find ways to save consumers money. So if we can move to something like Hadoop in the future, keep a small SQL provision that allows you to shrink your licensing, and maybe you use that for rapid event pulls or reporting, and then everything else goes into a Hadoop cluster, we're absolutely looking at doing that in the future. We don't have a roadmap on that yet, though. And then usability. So these are actually, the product team thought, they didn't even make this slide initially because they thought these things were irrelevant to big enterprise consumer customers. They're like, I don't think anybody will find these interesting. I was like, these are everything that we've been putting into releases for the DoD for the last year and a half, saying it'd be nice if we could do these things in the product, and they finally rolled them in because they got them in 5.9. So one of the things that DISA has always asked us for, and I used to work at the HBSS Helpdesk, and this was terrifying, was I used to tell people you have to label your policies. You have to version those. Because what you'd have is some guy who creates a policy called Frago 13 order requirements. And then somebody else would create a policy called Frago 13 order requirements. And they would apply those in two different positions in the EPO server. And something would be broke, or you'd be getting a block on something that you don't know why it's happening. And when somebody compares the policies, the policy names are the same, but the policies are different. And so you get this, this mind-crunching moment where no one understands what's happening, and they don't know how to revert because they don't have a policy version. So we in 4.6 and 5.1 created a policy comparison tool. So in EPO, you can actually pull up two policies if they're named the same, and we'll give you the delta in the settings. And then what we did in 5.9 is we actually now have a trace capability where we can say, where was the policy, what was the policy set? If it's not working and the previous one did, I can restore that previous policy. I can delete policies. I can actually revert back to a previous policy that worked. And so this makes troubleshooting a lot easier, makes consistency a lot easier. And we also have in 5.3, it wasn't on the slide, but in 5.3 there's this thing called impacted systems. So as you're making changes and you're getting ready to save that policy, when you hit save policy at the top, it's got this bar and it says you're getting ready to change policy on X number of systems. Because the big problem that we used to have is that people would have a policy and for some reason, because they just weren't looking at the, maybe they didn't filter right, they would say, I'm just changing it on these two systems. And then you would end up calling someone and saying, why did you just change all 100,000 assets to block this hash that doesn't make sense everywhere else? And so now when you go to change the policy, this little thing pops up and it says, you're getting ready to impact 100,000 systems, or 5 or 10. Are you sure you want to do this? And you click a yes or a no, which is very beneficial. Yes, sir?
So historically in the policy catalog, the different policies were unique based on policy name only.
Correct.
Is that still going to be the case in this version 5.9?
Yeah, so the way we're tracking them is we're actually taking, I think they're hashing them based on how they're stored now. And so nothing changes in the interface. You still can't really create duplicate policies unless they're in different catalogs. But what's going to happen is the way we're tracking the backend is it's not the name we're tracking. We're actually tracking the policy integrity itself and then tracking that as it changes. That's how we're reverting as well. So we'll do all that on the backend for you, but as far as impact to usability and training, nothing's really going to change except these new features. We've updated the HBSS training for these. And we'll update the documentation and guidance. Customizable event time. I think this one is just funny to me. So if you have a Bank of America and they have a nationwide deployment, they didn't really seem concerned that everything was standardized on UTC. That didn't really impact them. But we had DoD customers who were saying, I have assets in SWA, I have assets in PAC, I've got assets in CONUS, and these event times are all kind of funky, right? Like, is it local time? Is it server time? Is it UTC local on the asset? Is it UTC server on when it was received by EPO? I'm very confused here. And so in 5.9, another one that they were like, yeah, we can do that, it's not a problem, is customizable event times. So now you can actually set desired time zones, and then if you would rather your security analyst team actually look at the local time zone compared to when it was received at the EPO server, you can do that as well. Kind of helps with the forensics and traceability piece of it. And then agent uninstalls. This one is huge. As you remove assets from your systems, now all you have to do is if you remove the McAfee agent, you can click a button to say remove all product with it and just strip it all off. So pretty nice.
Let me ask you a question.
Yeah.
Sorry.
No, you're fine.
But, removing an agent fairly recently has been a real pain in the butt. Has it gotten easier to be able to remove an agent if you need to remove an agent, say, to install an upgraded agent or something like that?
Yeah.
Long time ago, you could just reinstall agents on top of each other, and it would break a few things.
Yeah.
It wasn't a problem. And then, as far as I know, removing an agent in order to install a newer, upgraded one or whatever is really a pain. So
Yeah, honestly, I haven't seen too many issues with the agent. I've seen a lot of, if you, for instance, have a protection tool like HIPS installed, and you want to remove HIPS manually, we intentionally make that hard because we don't want people to be able to, but I haven't seen that across the board globally. But yeah, I mean, if you're seeing that, I'd love to get the feedback. Couple quick things, then we're going to move through some of this because I think we're obviously taking some time here. Is we're changing the UI. So we're moving from UIs to UXs in a lot of our products. So instead of user interfaces, now we have user experiences. And so we want it to be, we want it to change dynamically with how you use the tool. We want that to change with your daily behavior so that what you're using is conform more to you than it is just a standard platform that we expect everyone to use it the same way. Couple quick things on these. These are what we're doing to help you. So we know that a lot of people that run HBSS servers are not DBAs, but yet you're responsible for a SQL server in most cases. So we created this really cool tool that gives you all this data. Are your indexes updated? What's your fragmentation? When's the last time you did a backup? Can you purge? Should you clean? How big is that? You check this in as an extension. It gives you a dashboard. It gives you all these recommendations. You do those recommendations. You become healthier on your SQL environment, which makes your life easier and also helps us support you in a better way. The second one that we created as a tool is this installation auditor. So this is going to require that before you upgrade to 5.9, you check this in and run it. And you'll see over here, we're making it very simple. You've got checks, X's, and yellow boxes. And so what we're going to tell you is before you run 5.9, we're going to run this and say, are you in a good situation to do the 5.9 upgrade? Because we're going to do database upgrades, we don't want this to be this long, excruciating time for you. So we've made this checklist, and we've modified it a little bit for the DoD, where now you run this. If everything's green, you execute your upgrade. If there's yellow or red, you take some kind of corrective action, or you call us, and we help support whatever those issues are as we move forward. Any other questions on EPO before I hand it over to Derrick to talk a little bit about what we're doing on the endpoints? No? Okay. All right, Derrick.
Thanks, Drew.
Yep.
Okay, microphone's on. Good morning, or I guess good afternoon at this point, everybody. Thanks for coming out. My name is Derrick Watkins. As Drew had alluded to earlier, I am I'm the Pacific rep engineer for the Pacific Territory. So based here in Hawaii locally, cover obviously the islands, Japan, Korea, Guam, the whole Pacific AOR. Been with McAfee for a few years. Prior to that, I was at Paycom, so definitely familiar with the mission here, with the composite. And today, so just on this segment, I'm just going to be talking a little bit about our new endpoint solution, our new endpoint technology. Has anybody heard or has anybody seen ENS or ENS 10, heard the phrase, or even perhaps seen a briefing or a demo of the technology? Anybody at all? All right, cool. So this is brand new for you guys. Any HBSS operators in the room? So who actually leverages and who actually uses HBSS from an operational perspective? So a few. Okay, cool. So basically what we've, so I mean, am I going backwards? Okay, there we go. Forwards, excellent. So basically what we're trying to do, or what we have done, is in the past, if you are familiar with HBSS and you have used it, you're deploying a lot of different, we used to call point products, a lot of different modules. You had the virus scan module, which does all your antivirus stuff. You had the IPS, or the HIPS module, which did all your host IPS stuff. You had policy. You had all these. All these segments and all these components that you would have to, obviously deploy individually. So what we've done is we've completely re-architected the way that we do endpoint now. So as opposed to just slapping some new technology over sort of like a legacy construct at this point, we've completely re-architected so you actually have a truly modular system. So now with ENS 10. It's a single integrated platform. So what you're going to be doing is you deploy one package, and that's going to contain your firewall. It's going to have what we call the site advisor. And it's also going to contain all the threat functions. So it's sort of combining all the elements that you sort of see right now within HBSS into one deployable package with a new lighter weight framework behind it. To make things obviously easier and more efficient, and it's also going to be giving you a lot more capability, as we'll see here in just a few clicks. So as I mentioned, the key modules with a threat prevention module, firewall, web control, and threat intelligence exchange. Has anybody heard of TIE or threat intelligence exchange? Those terms. Okay, so we'll talk about that a little bit later in the brief and also in the demo. But that's the core function of ENS. And again, the idea is to make it modular. So as endpoint technologies are going to slowly be more integrated into the platform, it's more of just a plug and play and not so much of a cumbersome product deployment process that we were, obviously, if you're working with HBSS, kind of familiar with at that point. So, but again, all managed through EPO and combined into a single, more lightweight and more efficient platform. So how does it work? So prior to the new concept, let's just say that if you're a HBSS guy and you're going through your HIPS logs, right? So you have a HIPS alert. Virus scan is a completely separate component of that. The firewall is a separate component. Nothing's really talking to each other. So what we've done, obviously corporately, as from our entire portfolio with this concept called security connected, we want to try to make your not only your entire network from the boundary down to the endpoint a little bit more intelligent with how these technologies interact and communicate with each other. It's it doesn't serve us any good if everything is operating in a silo and they're not talking to each other. So we wanted to obviously tackle that at the endpoint or at the boundary level, but shrink that down and contain that within the endpoint itself. So as a virus alert happens, the rest of the components are going to be familiar and be able to react and respond to that. So the more that so we've again completely re-architected the way that the endpoint looks, but also doing that with tight integration in mind. So that's definitely one of the largest changes. So, for example, the web control. Previously, as a separate component, you're going out there. You have a user who's doing a Google search. They go to a site. The site advisor says, the site may be unsafe. I'm not too sure, but there's really no other mechanism in passing that information along. Like, hey, I'm not sure about the site. I'm not sure about this file. But maybe I could invoke the virus scan piece to this to actually perform a scan before the user does it. So that's just kind of an example workflow of how a process like this would happen. Whereas previously, again, with tools operating in their own silo, they're only going to be concerned with, well, I'm only going to be telling you whether you can surf to this site, yes or no. But I'm not going to be leveraging the antivirus to actually do some malware investigation. So that's what's been fixed within ES 10.
So how does
Yes.
that affect your events that get generated? Like you're talking about with that silo configuration, you've got all these different generators, if you will, with the different events.
Right.
So if you get that coordination going on, then do you still get, like with your example, you get a couple of events that get generated from the firewall issues, and then maybe some other events that get generated by the IPS generator and stuff like that, or is that all been
Yes, correct. So it's not going to be like, so if you're examining the events, and traditionally you'd have your HIPS console or your HIPS view, and then you'd have your VSE view. So you would have the events trickle in. They would still be tagged or labeled as coming from whatever source. This is a firewall event. This is a virus event. This is a website event. So you'd still have an idea of where these events are trickling in and coming from. It's just going to be a lot cleaner to view them in the event viewer. So is that answer? Yeah, okay, cool. Yeah, so perfect segue. So is anybody in here responsible for any type of incident response in their environment, incident responding? Okay, does anybody use HBSS for incident responding at the moment? How do you do that right now?
Well, inside of our DCO cell, we have HBSS and our CMD.
Okay.
And so those teams collectively, if they see things across the network, they'll talk. But as far as an automated process, that's something we're trying to figure out and work through to get after some of that actionable intelligence
Okay.
that we're talking about here. But as far as the automated process, we're going to
Sure. And in the Baxter, I think you raised your hand as well. Anything to share about how you currently use HBSS to do incident response outside the general? Yeah. Do you do any like custom policy auditor or custom HIPs based off of what you find to try to take action? No. Okay. Yeah. So I mean, it's encouraging that a couple people are giving us some use cases. But obviously the challenge is currently, again, with all these products working in silos, is how do we piece together what happened over here on this one endpoint from exploitation to maybe data exfiltration. Like what happened? What was the process? It's still to this day a little bit of a cumbersome task to be able to pull logs and pull events from all these different points, even if it's just within that one endpoint, and then piece it together to be able to tell the whole story. So the way we've packaged this now with being able to view events, it gives you that history, it gives you that context, so that it's a lot easier to where as previously in a more manually intensive process, you'd have to maybe make a spreadsheet and pull all these events in together, and then try to manually build out a timeline of what exactly happened here and how did it happen and what events fired where. It's all been consolidated, and we'll do that for you. So obviously, if you are in the situation where you leverage this capability for incident response, it's going to make it that much more efficient and that much cleaner. Yes, sir.
So sometimes with incident response, it manifests itself in technical details. But, as I see, there is a systemic issue going on that caused that to occur. Some policy wasn't followed, somebody brought something in, triggered supposed to go in. Is that, and that's pretty cool. So I don't know if that's in the way of plugging back into your policies that you have stored in there. But a lot of these things can be prevented if you follow the policy and do what you're supposed to do. Is that anything that you would discuss with it?
We do that.
Yeah.
So if you get 2 clicks, so we consolidate, so narratives, right? One is we're giving you narratives.
Sorry.
Yeah, so so if you read that, it's instead of having 30 events and saying, are these all part of the same sequence, we're essentially saying someone tried to do something and the outcome was X and this is what happened, right? But if you give one more click,
Yep.
this is on the far right side is I think going to help you on what you're talking about, which is what was actually attempted, what was the outcome, and what prevented or would have prevented it. And all of that's now what we're calling more threat forensics. They're not necessarily events, they're clearly forensics of the threat that was either successful or not,
Right.
based on what your policy said.
So it's going to provide you a lot more context and in a more human readable fashion.
Yeah, so I'm intrigued by what would have prevented it.
Yeah.
How do you noodle through that one?
So it's a good conversation. We have a R&D project we're working on right now that essentially says what are the top 20 threats around the world? How should our products be configured to block those things? And then what is your policy set currently? So doesn't matter if you have a product, it's how it's configured.
Right.
So are you properly configured takes you a step past just saying, do you have the right product installed? And so we're trying to find the most efficient way to map that. So love your feedback.
So the top 20 people, top 20 issue people? So they all the people.
Usually attack campaigns.
Usually.
Yeah. What we're trying to track is what are the top 20 attacks being perpetrated in campaigns, across Asia-Pac, and that becomes the problem is the number of people that we would need. So we're trying to automate that. But it's a great point. People no longer just want to say what product do I need. They want to say if I have a product that's turned off, that does me no good. So how do I need to configure this thing to prevent attacks in unsealed environments?
And to your point, sir, so another thing that we are doing that sort of complements the HBSS or all the the endpoint approach that we're taking is also more from a human intelligence standpoint as well. So, for example, overseas in Korea, especially working closely with the government over there, but also our forces over there as well, having sort of that tie-in to the back end of McAfee Labs. So we have cells, I guess, if you will, within McAfee Labs that do this for a living. So if you're interested in a particular campaign that's maybe focusing in on your area or maybe focusing in on your forces within, especially, I can speak from what we're doing within the Pacific, but the idea is to branch that out further. But kind of infuse that human level of intelligence of what are our analysts seeing with regards to malware tying back to specific threat actors, and then how does that correspond back to how we're going to be able to change the threat posture within our endpoint technologies. So that's also kind of how we're kind of sort of going outside the scope of just looking at HBSS and just looking at the technology. We're bringing human level analysts that are reading this malware, specifically focused around certain actors or certain campaigns, and then distilling that and then feeding that back into the system. So you don't like Drew just said. So you don't just go from, well, this bad thing happened. What kind of patch or what kind of thing could I have what kind of security control could I have used to thwart that, but also giving you more context and what was the threat actor source? How is this being used against me and my forces here? And so that's also sort of a side thing that we're growing as well, specifically here in theater. Yes, sir.
Question: with this new endpoint security, are all the logs all of them forwarded to the EPO? Because right now there's some logs that doesn't make it.
You mean like the firewall logs and HIPs, right? They don't get forwarded to the
They're unified, so that one of the things that we did on ENS was we have one log location for all of the modules running inside of ENS, and there's actually one log. Well, there's two logs. There's the system log, like is the thing running, and it's kind of like log, service up, service down, and then there's the threat log, and that threat log is complete and true. Like there's not 6 more logs you have to go look at. So, but yes, all of that data is being pushed to EPO, and they're narrated, so they're easy to read. So you can put that on a piece of paper and hand it to a commander and say, here's what happened, right? But on the back end, we have all the individual events as well. So if you're trying to do forensics, you have all that detail. So we give you both. But yes, troubleshooting is much easier with this one, much easier.
Okay. Any other questions before we tackle deployment? And we'll go through this kind of quickly. I know Drew still has some more application control stuff to share, and we have a demo as well. So, but basically the idea, we just want to make it simpler to deploy. So again, if you're an HBSS or an EPO administrator now or operator, you know the process, right? You got to tackle those products one by one. This is going to be deployed as a single package, and you enable what you have to enable. So sometimes people are going to say, well, can it work with, if I have HIPs installed, is it going to work with HIPs? If the HIPS firewall is turned on, can I use the ENS firewall? So you're able to toggle between however it is you're going to be deploying this. So if you're going to be using this as a replacement to the HIPS firewall doesn't have to be turned on. And obviously there's some mechanisms in place where we can automatically help you with the deployment, so that some of the products that do currently at the moment sort of overlap. You're not going to be stepping on each other's toes. So yeah, the cloud on premises. So basically, what we have is we have two ways to deploy standalone, but most of it from an HBSS perspective is going to be handled through EPO, through the managed. But there is a standalone way that you can deploy the new endpoint module.
The one reason that we added that in here was because we had a lot of unique customers that said, if I have a machine that's disconnected, meaning I can't connect it to EPO, but I want the same HBSS protections, you couldn't locally configure the products. You could turn them on, you could turn them off, but the historical HBSS products, you couldn't actually go and configure, make exclusions, make exceptions. So we created ENS under the distinct capability that at the console, on the endpoint or server running ENS, you can make every policy change that you can do in EPO, you can do that locally. And so if you disconnect, you can make exclusions, you can make exceptions. Historically, if you had it connected to EPO, you disconnect and someone says it's not working, you would say, turn off the firewall, turn off IPS, which it's not a great threat.
Right.
It's not, you don't want to do
Exactly.
that. So what we give you the ability now is to say, well, you can make an exclusion locally, and when you reconnect to EPO, essentially the policy flushes whatever you've done locally and resets. So you can do both now. So you have equal protections on connected and disconnected assets.
And I was an operator previously. Oh, sorry. Yes, sir.
So after having heard what you just said, then are you planning or have you removed that HIPS admin
Yes.
backdoor?
So you're talking about the client UI. So yeah, how HIPS has a UI, VirusScan has a UI. Everything has its own UI, right? So the idea is that this is going to be one consolidated UI. And as Drew mentioned, you're going to be able to basically take action on the system as if you're sitting at the EPO from a policy perspective. Because again, as a former operator, it would be incredibly frustrating to go to a machine that is, for one reason or another, it's isolated, it's not communicating with the EPO, but there's some policy issues. And the only real thing that you had in your toolbox was to just turn HIPS off. And it's obviously not an ideal solution.
But we'll still have passwords. So I think what you're calling backdoor is what we would call local administrative rights. But I get your point. So one of the things that came out of the session last week with the Navy is the guy goes, that's great that you've consolidated all of the HBSS protection products into one common product, one patch, one policy, one deployable. But if right now I give a virus scan bypass password to a local administrator, turn off virus scan, he can't turn off HIPS. So there's some checks and balances. He's like, if I give him a password to unlock ENS, he can turn off HIPS, he can turn off firewall, he can turn off all of it. So one of the requests that they had, which is a great request, was can we do role-based password generation, where that password only unlocks a certain component of ENS locally instead of unlocking the whole console. So I took that back to the product team. They were like, makes a lot of sense. We'll work on it. But we'll always have a way to locally administer the product. It's just we've expanded what you can do locally now. Still a password, still time delayed. So you can give a password that's only good for a certain period of time and then resets. But yeah, it's a good question.
Cool. Moving on to the scan impact. So a common suggestion usually raised is about how, well, it's so resource intensive, right? Anytime that like virus scan is on the machine, it drags it down. There's all these, it's this drain on the resources. So one of the biggest changes we have within ENS 10 is what we call zero. So it's zero impact, meaning when it's going to perform its scan when the machine is idle. So if you're working, it's not going to be also at the same time scanning the binaries in the background, which is going to be a huge utilization saver. So when you but also when you resume, so let's just say that it's scanning because the machine's idle for 5 minutes, you come back on, you do 3 minutes of work, and then the scan is interrupted. But then after 3 minutes, you go and get coffee. Once the machine is idle again, it'll pick up the scan from where it left off. So you're not going to be like, okay, it had 5 minutes to scan, oh, but it got interrupted, 3 minutes, and then the guy leaves for lunch, and now you got to start all over again. So the idea is that it's just going to be a more incremental, non-disruptive process for scanning, and even like it says in the bottom, the reboot won't even disrupt that. So obviously, the going forward was to try to really tackle the utilization and the resource problem that we've sort of encountered in the past and previous iterations.
I know there's a product called Move.
Yes.
I don't know that anybody's ever used it. I've never seen
So
it.
Move is for virtual desktops, yes.
Yeah, so is that going to replace Move or augment Move?
So Move is a different technology in the fact that it's designed specifically for VDI. So the way Move works is you have an on-premise virus, antivirus engine that it gets offloaded to. Exactly. Exactly.
So, it's not that we took virus scan, put a new name on it, ripped the guts out of it, put it in this, and said it's something different.
Voila,
right?
yeah.
Like there's a slide I think next to the next one. It's called AM Core. So we replaced the virus scan core engine with something called AM Core.
Okay.
AM Core includes all of these benefits. So we're taking AM Core and replacing virus scan and Move, the engine that's actually scanning Move. We're replacing it with AM Core in the next release because it has a bunch of benefits, right? Better detection rates, heuristics. I mean, there's a lot there. So this is kind of the core premise of what's actually doing threat protection on the ENS platform. This will find its way into a lot of the other products that used to use the virus scan-based engine for scanning. Yep.
Okay, good.
Have you come across Move at all, as far as?
I only know the theory. I've never seen it in practice.
Okay.
It's deployed at
Oh, I'm
pretty
sure
large
it is.
Yeah, so it's part of this is license. So if
It
your
is, yeah.
command moves into a VDI environment, we would 100% recommend use Move instead of host-based products.
Right.
Because if you don't have to install it on the VDI, but you get the same protection, everyone benefits.
And we tightly integrate with other, with providers like VMware, for example, a big partner of ours. So if you have any, separate VDI Move requirements or questions, we can always, take that off to the side too, because it's something that we are seeing as well as more and more people adopt and start pivoting to VDI environments. Data exchange layer. Is anybody familiar with the data exchange layer or this concept? Okay, so new territory. Basically, so from a foundational perspective, from an architecture level within McAfee, we, to go back to trying to eliminate those technology silos, we've developed something called the data exchange layer, or what you'll hear called DXL. DXL, think of it as a communication fabric. So if something happens at this point of the network to a specific endpoint, how is that data or how is that intelligence going to further be able to propagate out? And also, how are all these technologies, whether it be from endpoint or IPS or firewall or gateway or SIM, how are they all going to be able to communicate in a rapid fashion? So what we did was we developed a system called the data exchange layer, or DXL. So previously, you can sort of see in this model, from an API-driven model, if you wanted things to interconnect and talk, you have to have a one-to-one API. Well, the problem is that if you got dozens of things in your environment that you're trying to communicate with, you have all these different APIs. API connected here, API connected there, and you just have this, kind of mesh of APIs. So the idea is that we're trying to go away from that, have one fabric, and everybody just develops that one API and plugs in. Then you get the benefit of talking to everybody else who is plugged into that fabric. So any questions on the DXL? But that's pretty much the foundation for all of our technologies, not just the endpoint and how all the endpoint pieces work, but also at a complete network level from endpoint all the way up to your boundary.
And I'll cover more use case.
Yeah. And I think, existing customer migration. So it's fair to say this is, examining the capability of ENS right now as it relates to HBSS. The idea is that it's not going to be a forklift, right? So you're not going to have to completely rip out and replace. We want to try to make it as seamless as possible. And there's a few ways that we're going to be able to manage that. Obviously, with HBSS, you have virus scan and HIPS. So those are going to be the two largest considerations in moving forward with ENS is, okay, how is this going to be able to kind of fit in with what we have right now with virus scan enterprise and HIPS? So we have a migration assistant, which is going to be able to help you identify basically what it's going to take to get you from point A to point B with the migration. Automatic migration and manual migration options. We're going to try to steer more towards the manual migration for things like preserving policies, so that way when you do migrate, you're not going to have to worry about recreating or transmitting all these policies. We want to make it, again, as seamless as possible, and one of the ways that we're able to preserve a lot of your existing policies is going to be through the manual migration. Just a list of the requirements of what you're going to need. Obviously, if you're within the HBSS build and you do see this coming, everything, this will all be sorted out in the HBSS build, of course. But just to kind of give you a snapshot of what it would take in order to get you to ENS. If you're looking at being an early adopter or participating in a program where you just want to evaluate it, here's some of the considerations from a technology perspective of what it's going to require. And then I'm going to hand it back to Drew, who's going to talk about application whitelisting.
Yeah. So real quick, one of the things that we've been working with DIS on ENS, the reason we're excited about ENS is historically when we look at HBSS, people are just like, there's too many modules, right? They have 5, 6 modules. Each of them have their own policies. All of them have their own events, stuff like that. And so we went to DIS and we said, new strategy, one deployable for Windows, Mac, and Linux. So you have one check-in package you'd check in, one extension, and one patch, one policy. So when we say, here's all the versions of HBSS you need, there's a whole list of kind of an Excel spreadsheet of different versions. Essentially now in the future, the hope would be that we would say you need ENS 10.2.2. And that's all you have to check. And if you've got that version, then you're good, right? And so we're building all of that in. But the cross-platform support, single patch, single policy, single deployable just makes a lot of sense for us as a company. Makes a lot of sense for customers. Makes it easier to use, easier to evaluate. One of the caveats for ENS is that as we move forward, because of the way we've built it, things like application control may find its way into that framework. And so from a customer standpoint, we get a lot of questions that's, as you guys develop new products, as you develop new strategies, what does that mean for ENS? Do I upgrade, and what is it? So what we've done is we made ENS very modular in the sense that as we come out with, so we just launched a new machine learning product. So everyone wants that additional detection rate using machine learning and kind of a big data pod. So instead of telling you go out and buy this new product and then install it alongside ENS, what we're essentially saying is we give you a license key, you go into EPO, you activate that license, ENS suddenly has that capability, right? So you don't have to redeploy anything. And so as we develop new product and things like that, you'll see us essentially just expand the ENS platform. The great thing for us and you is that since we're expanding the platform, it is smart in the sense that all of those modules on ENS are able to talk to each other locally on the machine, so they benefit each other. And so one of the really cool use cases that we launched at Focus, which is last week in our big security conference, is we've always looked at customers and said, I can catch patient 1, patient 0 is probably going to be a struggle because I either have to put that malware in a sandbox or have to do a cloud lookup or A lot of people, the standard rumor is that, generals don't want to wait 45 seconds for me to scan a file. Like if they want to click the file, they want to click the file. But you may, if I determine it's bad, I suddenly want to block that everywhere else in the environment. And so we started this strategy last year where we said, I can protect your entire environment based on one detection. One detection, DXL, like he was talking about, broadcasts that over a shared fabric, and everyone benefits from that one central detection. The problem was that we had to look customers in the eye and say, there's probably going to be a patient zero. I have a solution for how to remediate patient zero, but it'll probably likely occur. So what we did in ENS in this current release is we built this thing called Dynamic Application Containment. And what it allows us to do is for ENS to say, I'm going to do something additional with this file because it looks suspicious. But while I'm doing that thing, dynamically put it in a container and allow it to run. So the user still gets to do what they want to do, but if it's determined to be malicious, it doesn't ever impact the system. It's in the container. We wash the container and move on, right? So now we can officially say with confidence, we can literally protect patient zero. If there's an advanced threat and we have to send it to either a sandbox, cloud lookup, a partner, machine learning, whatever we do with that, say it takes 20 seconds to do that, user's not impacted. They're still doing whatever they think they meant to do, but you're protected because it's running inside of a container. All of that's built into the ENS platform with no human interaction. It's all dynamic. And so that's where we want to go. We want to automate. We want to turn most of your HBSS administrators into analysts, not operators. We're really tired of giving people hashes and saying, create policies, create signatures, push buttons, look at screens, try to build these events into a common campaign. We want to do all that for you and give you time back to say, how did the attack, what was the attack vector, what was the intent, what was the outcome, more operational. So given that as a caveat, you may see us roadmap application control into ENS in the future, which means you would just put in a license key and suddenly you'd have built into the platform. Right now, this is side-loaded inside of HBSS. If you're not familiar with whitelisting, there's good things about whitelisting. There's really problematic things about whitelist. If you've ever tried to whitelist a system, you essentially immediately assume that the whitelist is only as good as you are. So when I give somebody a file and I say DLL 2565 whatever .dll, is that a good file or is it a bad file? Like most people would say, okay, who signed it? That's a good place to start. Microsoft, okay, whitelist, right? But if you find self-generated files, which Microsoft does this, we do this, all companies do this, you self-generate, self-sign files that have never been seen in the world, and you say, is this file good or bad? You just make a guess, right? And as soon as you make one bad guess, your entire process of building a whitelist is gone. You have that one thing that suddenly just the integrity of that whitelist is shot. And then the second problem is even if you have NSA PhDs from MIT and they build you a whitelist, when you patch on that next monthly patch for Microsoft, especially if you've done it by hashes, most of your hashes are going to change. So now you've got a whitelist that needs updating, and that takes a lot of people and a lot of time. So those have been historically, like I said earlier, everyone's always agreed. Whitelisting, great idea. There's a reason the Department of Defense has not done it until this last year. There's no great way to do it. And so what we did is we created this product a while back, 3-4 years ago, and we've been slowly moving it into the DoD and kind of building messaging around it. And so now DISA is going to do, they're going to license this for the enterprise. Base concept is we land on the machine and we generate a whitelist, meaning that we pull everything into an inventory. And once we build that inventory, then we rate the inventory for you. And so what you'll see, I'll flip through since we're cutting short on time here. I'll show you the screenshot. So this is what you'd see in EPO. You can view it by application inventory, meaning you see application X and you can tell how many assets it's on, or you can view it by system. So if you have 10 systems, you can click System, Show Me the Inventory, or you can say, Show me the entire application inventory of my entire environment, and it just lists it in kind of an application view. What's interesting is we actually collapse these into applications. So if you looked at something like, alink.dll, and you're like, who does it belong to? What application's using that? No one knows. So what we do is we put them into the application, and what we do on the back end is we take all of those. We take digital signature, location, hash, and then authority. We send all those up to the GTI private cloud in kind of this massive back and forth, really lightweight protocol, and we rate them. And we say, here's everything that we know is good. Here's everything that we know is unknown, meaning we've never seen it before. And here's everything that we know is bad. By default, if it's known bad, we immediately not going on the whitelist, right? Unless you just change it yourself, which you have the right to do, but it'd be a bad idea. And so from that point, we can actually say, here's your whitelist. The only things you really need to be concerned about are these unknowns, right? And those unknowns become a problem because you're saying, self-generated files. Maybe I self-sign files. I have developers who create applications. McAfee's never seen them, so they don't know how to rate these for me. And I'll walk you through our solution for that. But the trick, if I flip back here in a second, the trick after that is how do we maintain it? Because you don't want to hire 50, 60 people required to update all the updates as you go through patch sequences. So what we've done is we do what we call a kind of a trust chain, and we say, what do you use to update your system? Do you use a person? Like, do you literally hire someone to go out and do updates? Likely no. So you're using something like SCCM, you're using a big fix, you're using, maybe you're actually allowing the application to update itself. Maybe you're using the Java updater to update Java on the systems. So what we do is we say, tell us the things that you're using to update your systems. Give us the location, the name, the hash, and the digital signature. And if we can validate those, then essentially we'll let them do what they do and dynamically append anything they do to the whitelist. So essentially we're by proxy saying, I trust you, so anything you do, I trust, and I update the whitelist. So the only time you really have to touch your whitelist then is when you add a brand new application, pending that you don't use a trusted authority to install it, because if so, it's appended to the whitelist, or you manually want to go in and modify something. Why you would do that, use cases kind of range on that. But the goal is that once we build it, we rate it, you review it, you put it in place, we update it based on a trust chain, you shouldn't have to touch it, right? And that's how, historically, everyone says, whitelisting servers, pretty straightforward. Server has a purpose. It's a web server, it's an email server, it's IIS. I know what's running, I can whitelist that. Those are good. But initially, DISA was like, we're not going to do workstations. That's insane. You can't whitelist workstations. You can when you build an intelligent whitelist and then update it dynamically. Yes, sir?
How would you do this like on an offline?
Sure. Yeah, so there's two tricky ways to do that, and there's one really easy way to do it. One is that we have a GTI cloud on Sipper, so we're working on a way to just point EPO at a Sipper version of our corporate cloud, because we do that today for NSA. The other way is, and we did this for Cyberflag a couple of years ago, is that we make what's called the offline tool. So everything reports to the EPO. You get a zip file. You take the zip file over to a machine that has access to the cloud. You download this little tool. You drop in the zip file. You get the same zip file back, but now it's said answered, and it pulls down the ratings. You carry the zip file back over to EPO. You check it in, and it imports all the ratings for you. The other way, which we just added, and this is actually how we solve the gray problem as well, is right now, what we've done in the past is known good, known bad. Gray is kind of on you, and we would help you evaluate those using professional services, or you could, if you have local sandboxes, Cuckoo, something open source you want to use, you could do that. And even looking at customers and saying there's 22 gray applications in your environment is still a lot better than saying, I have no idea how many applications you have, I don't know whether they're rated, and you don't even have a whitelist, right? So we made progress. What we've recently done is said, we have a sandbox, right? We have a sandbox that does static and dynamic analysis. Why wouldn't we just feed the gray files to the sandbox and let it tell us whether they're known good or known bad based on dynamic and static analysis? The way we're doing static analysis is if it's time delayed or virtual aware, which isn't really that hard to do anymore, what we do is we unpack it, decompile it, run it, and then we do latent code matches with known code families. And we say, 15% of it matches a known Zeus, 10% of it matches a known rat. This file's bad. Like, even if it won't run in the sandbox, we do static code analysis. So now what we can do is say, here's your good, here's your bad, here's your gray, shift the gray over to a sandboxing solution that runs all the gray, bring back whether it's known good, known bad, and at the end of the day, you shouldn't have any grays. And at that point, you update the whitelist, you put in your trusted updaters, and you go back to business.
So this gray is all done through GTI?
Yeah, the rating system's using GTI, yeah. So that.
And then this is all going to be unique on every system?
So the whitelist is unique on every system, meaning?
So in theory, if you had 10 workstations, you could have 10 different whitelists.
Correct. Yeah, so it's EPO-based policy, so you can have 10 whitelists if you want, or you can have a global whitelist, or you can have a whitelist for your servers, or you can have your whitelist for your Windows 10 systems compared to your XP systems. So it's.
But you're kind of describing kind of a behavior-based learning situation.
Yeah, so what it does when it lands on the endpoint, it literally grabs everything on that endpoint. Any, not just executable, any binary file. It's grabbing that, pulling it back to EPO and rating it. So yeah, technically, you could have one machine that has 100 applications. You could have one machine that has no applications. And what you'd see in EPO essentially is a list of applications in your environment. You can shift and view it by computer if you want, but the strategy and
It would be one generic
You can do that. Yeah, we expect, and what we've done in deployments is that doesn't happen, especially in the DoD. So what happens is someone looks at the total list and says, how many bad apps do I have? And you say, well, here's these 5. Okay, those are automatically blocked. Now here's all the good apps. Now is Firefox a bad app? No. Should it be used in our environment though? That's not authorized. Okay, so now I'm going to change that, right? So you have this global policy that allows you to dictate what applications are allowed to run globally and what applications are not allowed to run globally. But if you want to dictate on a specific system or a group of systems a different whitelisting policy, EPO allows you to do that by system tagging, applying a policy to a container. Like that's an EPO policy assignment maneuver. But the product, essentially, you tell it what application whitelist to authorize and operate on, and that's what it does.
So, just to review for my benefit, I apologize.
No, you're fine.
I have to listen to this, but, so you're using sort of the app locker publishing sort of thing with the certificates, right? That's part of the analysis that's going on.
100%.
And you're also including a blacklisting type of thing because via GTI, you're going to know what the
Yep.
bad signatures are. And then all of the white, so the whole issue with all this whitelisting stuff is managing.
Sure.
Right? And so this is kind of self-managing. It's kind of
Yeah, we want to automate as much of the decision. Like the decision's still yours, and that's I think I may have one of these screens, but for instance, we'll use Firefox again. You can go in and on the whitelist it'll say GTI global rating, known good. You can hit change enterprise rating, known bad, block, right? So you can override our ratings at any point you want. So you still have the decision-making authority. What we're doing is giving you all the intelligence we have and telling you what we think the decision should or should not be based on threat data.
But if you have a hash for a particular program that you know is infected or if the Trojan,
Drop it in and block it globally. Yeah,
that'll typically come down through the GTI.
Yep. Yeah, if we knew about it, and this is a great point, if we knew about it, we're going to put it in GTI and it's immediately going to show up dynamically. This thing syncs on a schedule, so we update the local reputation on a schedule in EPO. But hypothetically, the Department of Defense knows about a hash that they're not willing to give us because maybe it's on a TS network or something like that. Technically, what you would do today is you would go to HIPS and try to create a HIPS rule to block that hash, which does or doesn't work depending on how you do it. Now what you do is you just go into the EPO interface for application control, hit create new blacklist rule, drop in the hash, set globally or local policy, hit globally, walk away. Watch the events roll in as those are being blocked. Which immediately makes people say, how are you guys protecting the tool then? Because it becomes a massive target for attackers, because if they can't run their tools, the first thing they're going to do is attack the thing that's preventing them from running their tools. And so what we're doing is all the built-in memory protections that the operating system plus some of our own Kevlar protections give us, we're securing it to say even the applications that are allowed to run on the whitelist, we're protecting them so that someone can't try to use memory exploits to infect a known good application and use that known good application to do you harm. So we're not only preventing you from running bad apps, we're also protecting your running good apps from exploit. Yes, sir? Yes, it does pull scripts. That is a great question. I'll wait for your second one. Yes.
Second one is if something gets blocked locally on the local machine,
Yeah,
is not forwarded to the EPO.
it is. Yeah. Yeah, if you're connected, it absolutely will forward it. Yeah, all of our products push threat and event data back up to EPO for review and logging. Your first question about scripts is a great one. A lot of people in the DoD, there's been a big debate that we've had with customers that have rolled this out already. Should something like Python be allowed on endpoints? And who has a right to use it, right? And if you allow Python and Python calls another application, are we concerned about Python or are we concerned about the application that Python just called? And so we have a couple built-in protections for that. We do pull scripts back and rate those. A lot of those we have no rating on because they're usually homegrown scripts, startup scripts, something like that. What we've discovered is that change management is huge because when we deployed at CENTCOM, we found a bunch of startup scripts that no one knew about. They were like, what are all these scripts? I'm like, well, they're on the system. I don't know, right? I mean, we should look at those. But they were legacy things that people had used to map drives or something like that, and they just never removed them, right? I mean, which makes sense. And so as you go through, we do that. But what we've done with customers is to say, great discussion, should users be allowed to use Python or Perl or what interpreters are allowed on your endpoints and why are they being used, which starts a bigger discussion. From a protection standpoint, we can absolutely block those, we can allow those, or we can allow those with restrictions, meaning that as they launch additional apps, do we allow that to happen? Can we restrict and monitor what's happening as they launch additional applications? And so there's a whole kind of trust chain for that as well that we can build into it. And then this is a overview of how we update automatically. So we allow you to tell us a process that's updating your systems that we should trust, and we allow you to tell us a couple things about it. You can make a really bad decision and say, here's the hash of this process, and it's allowed to do anything on my systems. Like, the tool gives you the ability to still make bad decisions. What we would say is it really should be signed, even if it's a local signature, something you self-generated, it still should be signed. All processes, applications should be. But what we usually do is say, where does it run from? Is it signed? And what's the hash? And then you put that in, and whatever that thing is that you trust it does, we update. So we allow you to do processes, certificates. Directories are actually kind of cool. We've had a couple of customers say, I have users that travel a lot, or I have developers, and I need them to be able to install tools as they work, and I don't want them to have to come to me and request new applications being added. So they actually describe a personal folder or directory and say, my name, documents, whatever, and they wildcard it, and they say, you can install anything you want in that directory. And then they just kind of blanket that directory with additional protections, whether it's additional virus scan or something like that. And so essentially anything that's installed in that directory is automatically updated to the whitelist. So it gives them a way to do that. I don't see that happening too much in the Department of Defense. And I don't really see trusted users. The Helpdesk strategy, which is if you call the Helpdesk and the Helpdesk logs in your machine and they need to install an application for you to help the process, you can add users or user groups to a trusted group to say if this user is logged in the machine and they add an application, it's automatically appended to the whitelist. Works really good for Helpdesk processes. Works really good for VIPs. Maybe the general just wants to install whatever he wants to install, and he says, I don't really care. Sure, you can list him as a trusted user, and anything he does automatically put into the whitelist. Not probably the best security solution, but we give you some flexibility. Any questions on the app control piece? Yes, sir.
Question, trusted user at the bottom of the
Yeah.
Can you tie those to Active Directory users? Or
Yeah. Yeah, you can time to Active Directory users. The problem that we've been fighting for years is that DISA won't allow you to sync EPO to the domain, so getting Active Directory access from EPO is problematic.
So if the HBSS, if the EPO is not part of the domain, you cannot do that.
Right. Yep. We can talk afterward. There's a couple of ways that we've documented to work on that, but yeah. Any other questions on app control? Like I said, it should be coming to you shortly. We've done the contract piece of it. DISA's already done a ton of testing on it. I think what we're waiting on is there's a US Cyber Command order that's going to dictate how you're supposed to use it and what situations you're supposed to use it. Then they're going to release the licenses, and then there'll be some kind of task ord. I think right now there's a warn ord. I'd give you the number, but I don't remember it. But there's a warn ord out that says, warning, there's something coming. And so you can read that. If you have any questions, please let us know. More than happy to help. It's unique. I'm really excited about app control because it's the first product we've ever provided through the Department of Defense that actually allows us to shrink the threat surface. Everything else is just protecting the threat surface. We're going to monitor, we're going to detect. This one actually allows us to go in and say, if Shockwave should not be allowed to run, I'm going to remove it from being allowed to run, and I'm going to do that globally. Yes, sir? Yeah, so this is the other thing that I wanted to address as a last point on app control, and then we'll move on. This is by far our broadest, sorry, let me skip this for you. I think we all get that. It's our broadest swath of both supports, right? So this is also what we're going to use for XP and 2003 support. So that was one of the selling points for DISA was we know there's XP systems, we know there's 2003 systems, we know the DoD can't get off of them in the time frame we'd all like. We cannot support them with HIPS and virus scan and these other tools that are kind of intensive on the operating system. But what we will agree to do is lay down this application whitelisting approach kind of on top of the operating system and say that's how we're going to operate on XP in 2003. So yeah, the great thing about this too for tactical environments is it has a complete CLI, so command line interface. So if you have systems, we've put it on. It's great. We've put it on radios. We've put it on helicopters. We've put it on weapon systems. We use it for SCADA and ICS security. We've got a NIST mapping document for how this secures ICS environments. Whitelisting is a great tool, and a lot of people say, well, if I can't connect EPO, I can't use it. Not true. Complete CLI with an admin lockdown access. You can log in, configure it, do anything you need to do. So when we were talking to sub-commanders or captains, this is our pitch, right? If you go down, you don't get updates for months at a time. virus scan doesn't do you any good if you don't get data updates. Why wouldn't you just lock the systems with app control? And if you need to make a change because you're in maneuvers or something's happening and you're like, I need to add an application, you either use a trusted way of doing it or you just log into the CLI locally, put in the password, make the change, lock it back. When you get back to ship report, you plug into EPO, you get a new policy, you update it, right? So we're excited. This is going to be good for the Department of Defense. I think it's going to change some of the frustration with the orders, which historically has been, if the operating system supports it, you have to load the whole HBSS portfolio. We don't care about mission, we don't care about whether it's disconnected, we don't care how much bandwidth the system gets. If it runs the operating system, have to put HBSS on it. What we're expecting and what we've positioned is to say, if it doesn't make sense to put HBSS, full HBSS on it, but we can tell you with a straight face that the protection profile is equal to, or in some case maybe even better, using only app control, is that a fair shake? And the answer from DISA so far has been yes. So I think the orders will change to say, if your systems do these things or they have these behaviors, use app control only. And if your system is enterprise, normal enterprise systems, use HBSS plus app control. And I think that's going to be our order direction going forward. So we'd love feedback if people have it as they start using the tool. Any questions on app control? Okay. So now I think for the fun part, right? So we got, Okay, so we got about 20 minutes. He's got about a 3-minute video. So something that we constantly get asked is, what is our strategy for the future? HBSS has been around for a long time. Like I said earlier, we haven't had a great mechanism to update technology and product. So we're looking at this, HBSS renewal and new contract as a way to get some of this out there. So what I'm going to show you in this, we have deployed across multiple environments of the DoD. The Army is going to standardize on this. We got a pretty cool opportunity with them very recently to manage their cybersecurity infrastructure. So we're actually going to run as a service HBSS plus all the new technologies as a service for the entire Army network, all 1.2 million assets, something like that. But what we're telling people now is this idea that you should manage your endpoint, you should manage your network, you should manage your web gateway, your email gateway, your data center security, your web security, whether it's cloud security, and they all have their own interfaces. They're all different vendors. The reason that the Department of Defense hires integrators is because none of this stuff's integrated, right? Like there's a reason that those people exist. And so what we did is we said, what if we could create a system where I can pass information in a standard format to anyone who will accept it? I don't care who you are. It's just a publish, subscribe. So I'm publishing threat data, you're subscribing threat data. And the theory was, if I could go to the government and say, as long as the first checkbox on anything you buy is, does it integrate with said strategy, whatever we call it, and it says yes, then the base assumption is that day one, you take that new piece of hardware or software, you connect it to your environment, you start both generating and consuming threat data that your network is already generating, right? So it's plug and play almost. It still has its cool individual techniques that you bought it for, but at the end of the day, you would have assurance that if a firewall, a next generation firewall, which catches a malicious PDF coming into your environment, that same detection would happen if you had that same PDF on a USB and you plug it into a system geographically on the other side of the world that you own. Like that is the use case. I want the same protection at the top that I have at the bottom. And we kind of liken it to this NATO approach to say an attack on one should be considered an attack on all, and that we should protect each other equally. And when I say each other, I don't only mean your organization. I mean your organization, all the vendors in your stack, top to bottom, including your analytics and SIM technologies, but also your partners, mission partners, whether it's Department of Defense or technically mission partners inside the realm of whether it's NATO or something like that. So what we've built is this strategy, and the first thing that we got pushback on was, well, everyone's building a threat platform. Everyone's got their threat exchange. Yours is called DXL. Everyone has one. Cisco's got theirs, and Symantec's got theirs, and it becomes a problem because if everyone has their own threat exchange, then that means that we don't have a common threat exchange. And so we, under Intel's guidance, did a really cool thing, and last week announced that this is going to be open sourced. So we essentially said, don't have to pay us for it. We've created it. It works. We've got it scaled. This will scale this product will be across the entire Army network in the fabric that if an HBSS endpoint at Netcom detects a malicious file and it sends it to a sandbox for sandboxing, and that sandbox says, here's the hash, here's the digital signature, here's the IP addresses it was trying to communicate for command and control, within milliseconds, those indicators will be pushed across DXL to all connected devices, network devices, analytic devices, endpoint security devices. And if you tried to run that malware on a different endpoint or tried sending it through a web gateway or tried to maneuver it through a network IPS, it would be immediately blocked based on a detection that would say, this is known bad because it was detected in a sandbox in the environment. We can extend that to a different solution and say, right now we're working with SOCOM and CENTCOM, and they're saying we see a lot of the same threats. We operate a lot of the same battle spaces. Why can't the things I learn on a SOCOM environment, why can't I benefit my brethren over at CENTCOM over a common fabric? Meaning that if they detect something malicious in their network, I'd like to also pass it to them for protection. We took that one step further and said it would be great if the Army finds something that they could push it up into a global structure that DISA would want to evaluate because you want some kind of standard control. And if they said, yeah, that's something that we would like to block everywhere, that they could push a button and that would flow dynamically down across a broad frame to every connected device. The gateway for that was, well, if we standardize on that and everyone else comes up with their own solutions, what do we do? So we just essentially said, open source. We'll move it into open source. We'll let something like the OASIS body govern it. We'll still develop to it. We'll still integrate with it, obviously, but we'll let some community own it. And so now the Department of Defense or even mission partners will be able to build their own integrations into an open system. So we're excited about this. This is by far one of the coolest things we've done because it automates, right? We no longer have to have people manually push all these buttons. Essentially, now, like I said earlier, we're going to try to turn some of these operators into analysts. That's the big goal. So what the demo is going to show you is kind of illustrate what this is. I'm going to go over the quick components for you real quick. And essentially, when he shows you the demo, and when we talk about sandboxing, we call it ATD, Advanced Threat Defense. It's part of the SharkSeer platform today, if you're familiar with the SharkSeer platform and what it does. The reason that we do well in detection rates is because of the static analysis piece. We're finding more and more malware that just does not dynamically execute, whether it's time delayed, it's virtual aware, it knows it's running in a virtual environment, so it just won't run. So the ability to say, well, fine, we'll unpack it, we'll decompile it, we'll run a latent code scan, and we'll come back and tell you whether it matches latent code that's been used in other malware families. Great way to get additional detections, mainly because we all know this, malware authors typically don't create top-to-bottom new code. It's object-oriented program for a reason. They grab something that they like from a certain class or family, they dump it into their code, evaluate, change. But if we can say 15% of this matches a known Zeus, there's no reason it should run in your environment. Like if your programmers are using those code segments to build you something, you might want to reevaluate some of the practices there. So you'll see this as part of the demo. This, if we just focus on the far left side, we built an analytics platform, and one of the cool things that we're doing is we're doing retrospective analysis, meaning that if I find something malicious today, the question becomes, how do I know if maybe it's been in my environment for a really long time and I just didn't know it? So we're saying, here's an IP address that's exfiltrating data out of your environment. When was that IP address first seen? And so what we do is we take new detections in an automated form, and we push those over into this analytics platform, and it goes back in time across all of your log and event data that you've stored there, and it says, here's everywhere that this file was seen, here's everywhere the IP address was connected to, here's this hash that you just determined was bad, it's been running your environment for 2 years. And then we orchestrate some kind of cleanup based on that prioritization. And the way we do that is everyone has an EDR tool these days, endpoint detection and response. If you've been tracking that fun vertical, it was maybe 7 to 10 vendors 4 or 5 years ago, and now there's probably hundreds. There's probably people in this room that work for a company that has an EDR technology, endpoint detection and response. So, but the way to look at it is I need a way to do forensics. I need a way to remediate systems. If I want to kill a process, delete a file, look up a registry key, or in English, look at the console and say, I would like to see the MD5 hash of every running process on every machine in my environment. Not many people can do that today with the technologies they own. So what EDR addresses is that remote management of a disparate network and the ability not only to do reconnaissance and hunting, but also remediation. And so you push packages, you drop triggers. You could drop a trigger that says, if this registry key is ever created, I want to block it and send up a red flag immediately. So you're almost like kind of just placing a trigger or a trap and saying, I know that this threat actor that's attacking us typically does these things. I'm going to put these triggers out there and wait for one of those to go off. Or you can say, show me everywhere that registry key exists. Here's 500,000 machines. Cool, delete that registry key. Awesome. And then, within milliseconds, it's all done and finished. So he'll show you some of that as well. And then if you want to go ahead and, we call these follow the dots. These are fun. So just close up to make sure we're all on the same page. Endpoint, we'll assume that this guy has HBSS or ENS running on him. Detects a file, doesn't know if it's good or bad, so he sends it to a local intelligence platform that's a virtual machine that runs alongside EPO. And essentially what it's doing is it's pulling in threat feeds. It's looking at the GTI cloud. It's looking at other threat feeds. It's looking at Shark's here feed, depending on what networks you're on. And it says, does GTI or someone else know if this file's bad? Essentially just doing MD5 lookup. Anybody ever seen this before? The answer in this solution is no, no one's seen it before. So typically what would happen is the endpoint would get an answer that says, we don't know if it's bad, so you're just going to run it, I guess, based on your policy. So in the new solution, what happens is it passes it over that open DXL fabric that we were talking about to our sandbox, and it essentially detonates the file and says, this file is 100% bad. Like, it's suspiciously packed. When we ran the thing, it was a keylogger. It tried to disable the antivirus. Okay, bad. So from that stance, what happens is it distributes all these indicators across DXL. So one may go up to your cloud environment, and then the rest of them may go to endpoints in your network boundary unit. So in a perfect world, this would be something like JRSS, meaning that a single detection at any one endpoint technically could be distributed over OpenDXL to JRSS and protect everyone else in the DoD networks against that type of threat. And then at that point, you know that your environment is protected. So what we do in addition is what I was talking about a second ago. We drop that record, all those IOCs, over to our analytic platform and essentially say, start doing some retrospective analysis and find out where this stuff's been in the past. And then what he's going to show you in the demo is that once that happens, our analytic platform over DXL, that open fabric, can essentially orchestrate a cleanup maneuver with our EDR technology. It can go out, hunt, find, remediate. And at the end of the day, if you're an administrator, you're looking at that one analytics platform and you see all of this stuff happening, but you haven't done anything. The tool's doing it all for you through a closed loop automation based on policies. And at the end of the day, you're looking at something more interesting, which is how did this threat come into our environment? Was it targeted? Who was the actor? Can I do some kind of association to a known campaign? What you're not doing is running around to all of your different interfaces saying, I think I've got a hash. Let me go to these 15, 20 different interfaces and put this hash in, right? So hopefully that makes sense. I'm going to disconnect real quick, take some questions while he plugs in. Any questions on the strategy or the platform? Okay. Well, in that case, I was hoping there was a question. We're going to take a hot 15-second break until this comes up.
Yeah, it should be up here in a second.
There we go.
There we go. Okay. So how does this look in real life? So we saw it on the slide. We saw the bouncing ball. We saw things kind of pinging back and forth. Drew did a great job explaining the components, but how does this work in real life? So the demo that I'm going to show you is we basically have two windows open. We have a virtual connection to a sample machine, our host, with an email client open. And in the other screen, we have EPO. So think of that as your HBSS platform. So in this scenario, we're basically going to be we're examining the activity of a user. They have an email that looks interesting. It's TSA. It's like, hey, open this email, and it's an offer to register for TSA pre-check. So the user opens the email. It takes them to a TSA looking site. They go ahead and they click Get Started. And we're going to see something here with the website basically asking them to execute some code, which is always a lovely idea. So again, to just further the use case along, we're just going to go ahead and assume that the user is really excited about running this code, and they're going to hit yes, and they're going to hit run, like you do. And then so what's going to happen is ENS at this point is going to come in and say, I don't have a reputation. I don't know about this file. Are you really sure you want to run it? And they're like, yeah, I'm super sure I want to run this thing. So of course they run it. And now to kind of, to caveat here, so yeah, they say, thank you for installing our code. But you see here in the background in the lower right-hand side, you see something pop up. So what just happened? Basically, what you saw here originally with the ENS screen that came on the bottom was you can also throttle that. Of course, we left it open for the purposes of the demo to have the user to be able to select yes and allow. But what just happened? So in the background, we're switching over to that analytics platform that Drew was talking about. And we're going to go ahead and open up a dashboard, our threat intelligence dashboard. So what's feeding this dashboard is a few things. GTI, which is our private cloud like Drew had alluded to. We also have other threat feeds. So if you subscribe to a third-party feed, or if you're importing third-party feeds like through Stix format. But also this is all the locally generated IOCs that you have in your environment. So in the background, what you just saw, that whole thing was Drew's slide about with the ball bouncing back and forth and all these different technologies acting together to be able to thwart this attack. So how you can view that in one area is through this, is through what Drew had talked about with our analytics platform. So ENS said, "Are you sure you want to run it?" User says, "Yes, of course I want to run it." ENS takes a copy of that file and sends it to the TIE server and says, "TIE, do you know about this file, yes or no?" Depending on what happens, TIE can either say, "Yes, we know about it," or "No, we don't." If TIE doesn't know about it, then it'll send it to the sandbox. Sandbox will evaluate it. It'll convict it, or it'll evaluate the code both statically and dynamically to see what happened. So now you see with what happened automatically is when that user clicked onto that file was then submitted to the TIE database. So now it's part of the system. And as you can see right here, I'll go ahead and pause this before it gets any further. There's a few different columns here. So the enterprise reputation, this is something that you can set. So if you receive, let's just say you receive a piece of intel from the community, you subscribe to something, or someone a buddy of yours works at a different shop, and they say, "Hey, here's a Stix file of a new IOC for this threat actor. You should put it into your environment." You know it's bad. So you can set the enterprise reputation as, I know it's bad. There may not be a signature out there that says it's bad. VirusTotal may not know about it. Even GTI may not know about it. But locally, I know for a fact because I recognize the source and I trust the source that this is bad. I'm going to set it as known malicious. But you see here, enterprise reputation isn't set. GTI reputation isn't set. ATD reputation, on the other hand, says that it's known malicious. And what that means is that the sandbox, so a truly zero-day piece of malware is going to go undetected, and it's going to be submitted through all these checks and balances. If it gets to the point where nobody knows about whether or not this file is truly malicious or truly good, it'll get sent to the sandbox. And this, again, happens all automatically in the background. Sandbox does its dynamic analysis, also runs it through a few other mechanisms as well. But at the end of the day, if this thing is truly, truly, truly unknown and nobody knows about it, the static analysis will unpack the code and review that code line by line. And like Drew said, if it has X amount of percent matching a Zeus variant or some other kind of malware family, that'll be discovered and revealed in the static analysis process. So while this, other components may not have a signature for it, at the end of the day, the sandbox did convict it and say that it is no malicious. So now you have the TIE database, which is that central threat repository on site, now knows that this file is now malicious. So when you saw the ENS prompt say, "Are you sure you want to run this?" and the guy said, "Yeah, run it anyways," it still allowed that to run, but in the background, that file was submitted to the sandbox. Sandbox evaluated it. Once the sandbox convicted that file, it sent that conviction back to TIE. TIE says, "Oh, wait a second, that file is bad because the sandbox just evaluated it." TIE dynamically sends that information out and propagates that out to all the endpoints. And now all the endpoints now know that, now I know this file is bad. Anybody that has this file, delete it. And the last thing what Drew was talking about with regards to that backtrace capability, where you can historically scan your environment and find out where else this happened. You can see right here, it may be a little bit difficult to see, but at the same time, the sandbox submitted this to our analytics platform, and we basically generated our own local IOC. So now you have things like you have the file hash, you have the file name, and you also have some additional hash information. If it was revealed that there's some sort of embedded IP address that that's like a C2 manager within the code, that'll be embedded here in the IOC. So what you could do is you could say, well, now I want to go back and search my logs. Has anybody else ever had? And it could be a different file name, but it has the same hash. Or it could be anybody communicating with the IP address that was drawn out from this file. Perhaps a year ago, this file existed in a different format, in a different type of code, but it had the same callback IP. So you're basically able to go back and historically search through your logs to find out, okay, well, have I seen any of these other indicators in the past 6 months or in the past year? And if you want to take action on that, again, you're able to, through the DXL integration, you're able to pivot back to EPO and use the EDR solution that we have that says, go out and find anybody that has this file name. And obviously, this is highly customizable and circumstantial. So depending on what it is you're looking for and how, you can go out and query and say, does anybody else have this file by hash, by executable name, by file path? And if so, and if they do, take X action, kill the process, delete the file, whatnot. So this is sort of an example of how you're able to orchestrate all these different network defense or endpoint defense capabilities, but from one platform. And that's kind of that's the central theme here, is to consolidate everything into the smallest footprint as possible, make it into one platform, and make it highly integrated so that things are not working in silos anymore, but they're operating in a truly integrated fashion. And that's pretty much all we have. So, oh, yes, ma'am, question.
Just a quick question. So the initial infection boxes that the malware was downloaded to,
Yes.
that kill process, is that manual for that initial box because it's already executing the code?
No, yeah. So what happens is, again, in the background, as that patient 0 was executing the code, in the background, Ty was handing that off to the sandbox. Once the sandbox did its job and evaluated the code, it said, no, the code's bad. Now the Ty server, so the Ty is going to act as like it's almost like a broker for everybody. So now the Ty's going to say, well, now I know it's bad. Enterprise-wide, here's a new set here's a new policy that basically suggests that if you see this file, you now delete it. So in the process of that one machine executing that code, once it was done, once Ty had now convicted that file, the new policy was pushed out, and that machine said, oh, I am running this code now, but now I know it's bad, so stop and then delete and clean.
Yeah, it would just stop
Yeah.
the process. Yeah, and you'd get an alert that said, I saw 15 machines running a process that was determined malicious, and I killed all 15 processes. So
Right.
as a security administrator, you'd say, I found 15 machines, I remediated 15 machines, I should be healthy, right? I mean that.
And with the EDR solution as well, it's also a good verification mechanism, because you could say, well, Ty, okay, let me just everything is updated. Nobody should be able to run this executable, but I really want to make sure. So let me go out there and I'll run a search and say, does anybody else have this? Yes or no? And you can say, okay, it really was just that one machine. It wasn't anybody else in the environment. And that's fantastic information to be able to give up to leadership and a commander who have these kind of questions, either in a real-world operation or an exercise, when they say, oh my gosh, red team is hitting us with this malware. Where is the malware? Where is it coming from? Whose box is it on? And you're like, oh, well, let me go to HBSS, or let me go through all these other manual processes and get back to you in like a few hours. This happens all automatically, and it happens in an instant. And again, this can all be reported and easily communicated and shared, so that way leadership is getting answers to the questions that they really need to know, and they're just not being bombarded with a bunch of, they're up, it's like, well, I got a room full of people telling me all this cyber stuff. I just really have like 3 questions, and they're really simple. Like, do we have this, yes or no? How bad is it, and what can we do about it? Like this workflow, and this process helps solve those problems.
Derrick, let me just add a couple
Yep.
points. So we've been focusing also on the endpoint, but this is a fabric and it touches different devices. So the same rules that allows an endpoint run or not run something will automatically feed it to the IPSs as well. And most folks in the room here run our IPS technology too. So it'll dynamically immediately create a rule that on the IPS it will also block it. And everything's consolidated through this analytics platform, so that now we get to the point where I can go in that room coming back with the information in a few minutes, right, near real time. I can go, sir, ma'am, here's the information. What do you want me to do? I can keep monitoring, capture more information. I can shut down half of them, contain. I can come back and then give you information of where it came from and where it moved. Because we've seen the scenario where, for example, you get an MD5 hash, and then you see that device or that service talking to an IP server. That shut down maybe a week ago. But we now can go back and say, tell me who else was talking to that IP address a week ago. And you find that there were actually 5 more MD5 hashes. So we could be in a scenario like, for example, in Korea, JCC might give an IOC, and then we think we're dealing with one IOC, but actually there were 5. And how great to be able to come back and, again, right, say, sir, ma'am, we actually found that there's 4 other IOCs tied to this one IOC you gave me. And now that information from Korea gets fed down to UserPack and down to Paycom, and now we're following it down here, right? And it might be that we found it here. So that's how we're getting all these connections really coming together from an AOR and hopefully right worldwide. So.
Yeah, no, thank you for coming. Hopefully
Yeah.
this is beneficial. We have a booth, so if you have additional questions, I think we have to get out of this room for the next session. But we have a booth, so if you have questions, love to stop by and chat. Thank you guys.
Thank you.
Appreciate it.